So we added this image validation and we show an error if we don't have an image. We also added the Firebase storage package already. So let's now make sure we can also upload an image. For that, back in the auth form, we do collect that user image file and we validate it here. And if we make it past this validation and everything is valid, we want to make sure that we do actually also provide that image file to the auth screen, because in the auth screen we send all that data to Firebase, and uploading the image will now simply be an extra step we should perform here. We can of course pass the image to the auth screen just as we pass the other data. Here, when we call that submit function, which we get from the auth screen, besides passing in user email, password, and username, we can also pass in our user image file. And this might be null if we are logging in, but we can simply make sure that we don't care about the file in the auth screen in the login case. Now, of course, this currently doesn't meet or doesn't fit our function signature. We should make it clear here when we define the submit fn that after the username, we expect to get an image file. But now we also need to adjust this in the auth screen, of course. There, we also need to add this. On the submit auth form method here, we should expect an image file, and file, as you learned, is of course imported from Dart.io, like this. So now we get this image file, and yes, it might be null in the login case, but we don't care about this. We won't use the image there anyways. But with that provided here, it should be available if we are signing up. And therefore here in the sign up process, we now want to upload the image. And I want to upload the image before we write all that extra data to our users collection, because a path to the uploaded image should also be something we also write to that users collection in the future. So we want to start or perform the image upload here before we write our extra user data to the users collection. Now for that we need this extra package, the Firebase storage package, and from there the Firebase storage Dart file. And that Firebase storage package can now be used here. We use Firebase storage, and again we got an instance property here, just as we have it on Firestore and Firebase auth. And this gives us access to this one global Firebase storage instance, which is pre-configured with the token and with everything. And there we now can call ref. Ref gives us access to our root cloud storage bucket. And to fully understand this, let's actually have a look at the Firebase cloud storage in the Firebase web console first. There we had a look at authentication and database. Now we're going to work with the storage. So let's click on storage to see how that looks like. Now, as always, here you can learn more about it through the docs and so on, but we can just click on get started. And first of all, just as with the Firebase database, just as with Firestore, we need to set up some rules. And we can simply click next here. This will be the default rules and they will be fine for us. And click on done thereafter. And this does something which is called create a bucket. In Firebase storage, you can upload any kind of files, not just images, and those files will be organized in so-called buckets. And your Firebase project comes with one bucket. Now in that bucket you can have subfolders and so on, but you will have this one main bucket. And this main bucket is what ref will refer to if you call it like this. It will basically point at this root bucket. Now in here, you can store your files. You can also upload them manually. You can create a folder here, as you can see, and you can do more things. You can also add a new bucket, but that would cost you extra money, so I wouldn't recommend doing it here, especially since you can create subfolders. One bucket should be fine for many kinds of projects. Now, just as your database, your storage also can be protected with rules, and the rules generally work in a similar way as they do on Firestore. You can dive into the docs to learn all about them, but you can see it looks pretty much the same. Here, however, we don't operate on collections and documents, but instead on our buckets, and we only have one bucket here, but you could have more than one, and then our paths in the buckets, so our folders and files. But besides that, the rules are very similar. And here, for example, we're saying read and write access to any file is granted if you are authenticated. So unauthenticated requests, which are not coming from logged in users, are denied. And that's of course great because we don't want anyone to upload files or to look at our files. Only authenticated users should be able to do so. And I will go one step further. I will not grant write access here, but only create access. So that deleting and changing files is actually not possible for anyone. Because in this app, let's say, we want to allow users to upload files and to view images, but we don't want them to be able to delete files. We can always do this manually here from the console if we want to clean up storage, but users won't be able to do this in this app. But of course, you can have a very granular control, and you can fine-tune this to your needs and to your application needs with help of the official docs if you need a different setup. So with that, however, upload and viewing of files should be enabled for authenticated users. And now let's go back to our code. With ref, we got access to this root bucket, and on ref, we can now call child. Child simply allows us to set up a new path, and that allows us to control where we want to store a file or from where we want to read a file. And here, that should be a string. I will point at a user images path. Now this does not exist yet, but it should then automatically create such a path. So that will create a user images folder in the end in which the image should be stored. And for that, I'll chain another child call. Because this here should be the folder where the image is stored. Now we need to give the image a name. So here, if I then store this as image PNG, it would create an image PNG file in that folder. Now, of course, I don't want to hard code the image name here though, because otherwise we would quickly run into name clashes where we have multiple images with the same name. Instead, I want a unique name per image. And I, of course, also want to make it easy to map this image to a user. Hence, we can simply use the user ID as an image name. Now, we get that ID from auth result here. There we have that user field with the UID field. And UID is just a string. And all we need to do now is we need to append the file extension. And that should be JPEG because by default, images taken with the device camera will be of type JPEG. So what this does now is it sets up a pointer at this path on our storage. But right now, of course, this path does not exist. We neither have that folder, nor do we have that file there yet. And this alone won't start the upload. Instead, this returns a so-called storage reference, which is a pointer at a certain path. So we can store this in a ref constant and now start the actual upload to that path which we now configured by calling ref put file. And this will do what the name implies. It will put a file to that path and it will use this last segment of the path as the file name. So in this case, the user ID with JPEG at the end. Now the argument we need to provide to put file is the file we want to put there. And that's of course this image we're getting here. So I'll just pass image here. Now you also can provide a second argument, which is storage metadata, which you could set, where you, for example, can add custom metadata, set the language of the file. But at the moment, I don't want to do that. Instead, I just want to upload the file like this. And of course, putting a file takes a bit longer, which is why this returns a storage upload task. This is not the same as a future, but it has the same idea, basically. Unfortunately, we can't await it because it isn't a future, but we can actually use the onComplete property on it, which will give us a future, and we can await this. Now, the task itself without onComplete also has more. We can check if it's currently in progress, if it's canceled. We can listen to various events which are emitted, which, for example, allows us to track the upload progress. But here I just care about the general completion, which is why I will listen to this onComplete future. Well, and with this, before we do anything else, let's save that and let's see whether this works. So let's create a new account with test4@test.com maybe, some password, and with an image, of course. Like this. And let's click sign up. Whoops, provide a valid username. Let's click sign up. And we continue. I don't see an error here, so that's looking good. And now let's reload our Firebase storage view here in the web console. And you should now see a user image folder. And in there, this JPEG file. And if you click on it, you should also see a preview here on the right. And this is the file we just uploaded from our device. And that's great because this now is the user image we just picked. So the file upload is working. But of course, now we want to do more. We want to make sure that we also get a link to this image, which we can use to load it, for example, in our chat screen to show an image next to every message. So that is what I want to work on next.